Aviation disasters are rarely simple events. They're these, complex chains of failure, where just one small error can, cascade into a catastrophe. For a while, the crash of Air India 171 seemed to fit this familiar albeit tragic pattern of potential human error in the cockpit. The initial theories kind of centered on mistakes that pilots might make under pressure, especially during those critical moments right after takeoff. Investigators and analysts looked at the possibility of flaps being retracted too early or maybe set incorrectly. Simple mistakes that could rob a heavy airliner of the lift it desperately needs to climb away from the ground. But this narrative, while plausible, was really built on incomplete information and the absence of clear evidence pointing anywhere else. However, the story of Air India 171 has been, fundamentally rewritten, and this dramatic shift isn't the result of like a leaked report or some government press conference, but rather the emergence of a new piece of civilian-shot video footage. This clearer, higher-quality recording actually captured the aircraft in its final, desperate seconds of flight. It provided a perspective that was previously unavailable, allowing for a far more detailed analysis. What this new evidence suggests isn't just a simple mistake in the cockpit, but a far more terrifying and systemic emergency. A complete and total loss of power from both of the aircraft's advanced jet engines. So now, the focus has moved away from the pilot's hands and toward the very heart of the machine. This new theory, honestly, changes everything we thought we knew about the flight's last moments. It presents a scenario that is one of the most feared in modern aviation: the simultaneous failure of two reliable engines on a state-of-the-art Boeing 787. Such an event is, statistically improbable, and raises some pretty profound questions about the aircraft's design, its maintenance, and even the fuel it was carrying. The crash is no longer just a story about a potential pilot error. It's now a deep and unsettling mystery about a catastrophic mechanical or systemic failure that occurred at the worst possible moment, just a few hundred feet above the ground. The investigation has basically been reborn, forced to follow a new and more alarming path. The clues that were once overlooked or maybe misinterpreted have now taken on a powerful new significance. A faint sound, a brief flicker of cabin lights, and a small, almost unnoticeable protrusion from the belly of the aircraft have become the central pieces of a puzzle that points overwhelmingly in one direction. The narrative has shifted from a question of what the pilots did to a more profound question of what happened to their airplane, leaving them with an impossible situation and no time to recover. This is the story of how a single piece of video transformed our understanding of a modern air disaster. Deep within the fuselage of every modern airliner lies a small but critical device, a last line of defense against total disaster. It's called the Ram Air Turbine, or RAT. Basically, it's a small propeller connected to a generator and a hydraulic pump designed to deploy into the airstream if there's a catastrophic power loss. The RAT is, honestly, an emergency system of the highest order, an electromechanical savior that is rarely ever seen or used. Its only purpose is to provide essential electrical and hydraulic power to the flight controls when the main engines and auxiliary power unit have failed, allowing the pilots to maintain control of the aircraft and attempt a glide to a safe landing. The RAT is not a device you can just deploy casually. On a sophisticated aircraft like the Boeing 787, its deployment is automated and triggered by very specific and dire circumstances. There are only 3 conditions that will command the RAT to drop from its housing and spin to life: a complete loss of power from both engines, a massive and widespread electrical failure, or a complete failure of the aircraft's multiple hydraulic systems. When the RAT is deployed, it's an unambiguous signal that something has gone terribly wrong. It's the aircraft's own declaration of a major emergency, a mechanical cry for help that bypasses any human input. The significance of the RAT in the context of the Air India 171 investigation just can't be overstated. Its deployment is not just a clue, it's a smoking gun. If the RAT was indeed deployed, as the new evidence suggests, it immediately invalidates theories that rely on minor pilot errors. A simple mistake, like retracting the flaps too early, would not trigger the RAT. The system is designed to ignore such events. Its activation points directly and almost exclusively to a total loss of thrust from both engines, or a failure so systemic that it mimics a dual engine out scenario from the aircraft's perspective. The presence of the RAT changes the entire framework of the investigation. So confirming the deployment of the RAT became the central focus for analysts examining the new video footage. Proving that this small, hidden propeller was in operation during the final seconds of the flight would provide a definitive answer to the question of what kind of emergency the crew of Air India 171 was facing. It would tell the world that the pilots weren't fighting with their aircraft's configuration, but were instead grappling with a complete power failure at low altitude, a situation that left them with virtually no options and even less time. The rat is the key that unlocks the entire mystery. Initial videos of the Air India 171 crash were grainy and shot from a distance, offering little more than the tragic arc of the aircraft's final moments. They were enough to confirm the event, but, honestly, just too poor in quality for any detailed forensic analysis. The new video, though, was a total game changer. It was sharper, more stable, and actually captured the Boeing 787 from a side profile as it flew past the camera. This clarity allowed analysts to really scrutinize the airframe for abnormalities, and they quickly found one. There was a distinct protrusion visible on the underside of the aircraft's belly, near the wing root. This was the open door of the rat's housing compartment. That visual confirmation was the first major breakthrough. The door to the rat compartment does not open unless the rat itself has been deployed. Its position, clearly open in the video, was unambiguous proof that the aircraft's emergency logic had commanded the turbine to drop into the airstream. But the evidence didn't stop there. Upon even closer examination of the enhanced footage, a small, faint gray dot could be seen just below the open door. This tiny detail, almost lost in the pixels, was the rat itself, its two small blades spinning furiously as the aircraft moved through the air. The visual evidence was now complete and, honestly, undeniable. The deployment of the rat at such a low altitude is a chilling indicator of the severity and suddenness of the emergency. The system is primarily designed for high-altitude flameouts, where pilots have tens of thousands of feet and many minutes to glide, troubleshoot, and attempt to restart the engines. The rat provides the essential power needed to perform these procedures. For it to be deployed at just 400 or 500 feet above the ground suggests an instantaneous and complete power loss right after takeoff. There was no time to glide, no altitude to trade for speed, and no chance to go through the lengthy engine restart checklist. This single visual clue, a small open door and a spinning turbine, rewrites the entire sequence of events. It tells us that the pilots weren't struggling with a lack of lift from improperly configured flaps, they were contending with a total lack of thrust. The aircraft had become a glider just seconds after leaving the runway. The landing gear remained down not because of a pilot error, but likely because with a total power failure, the pilots were focused on maintaining control of the aircraft, and retracting the gear was a secondary concern. The video evidence provides a silent testament to the impossible situation that unfolded in the cockpit. Beyond the visual confirmation of the deployed Ram Air Turbine, the new footage provided another crucial piece of evidence: its sound. The original audio track accompanying the video was of a much higher quality than previously available recordings, and it captured a distinct and unusual noise as the aircraft passed overhead. Instead of the deep, roaring bass of two powerful jet engines at takeoff thrust, the audio revealed a high-pitched, piercing squeal or whine. This sound was not consistent with the normal operation of a Boeing 787's engines. In fact, it was the sound of their absence. This unique auditory signature is the characteristic sound of a rat spinning at high speed. The small turbine designed to generate power from the airflow rotates at thousands of RPM, creating a noise that's often described as a high-frequency prop sound. To confirm this, analysts compared the Air India 171 audio to other known recordings of 787s landing with their RATs deployed for various reasons. The similarity was, honestly, striking. The sound in the crash video was a near-perfect match for the sound of a functioning rat, providing a powerful acoustic fingerprint that corroborated the visual evidence of its deployment. The presence of this sound, combined with the relative quietness where a jet engine roar should be, paints a vivid picture of the flight's final moments. The engines were not producing significant thrust, they were either windmilling uselessly or had spooled down to near silence. The dominant sound was that of the emergency turbine, a desperate mechanical scream that cut through the air. This auditory evidence is critically important because it is independent of the visual analysis. It provides a separate, converging line of proof that points directly to a dual-engine failure as the primary cause of the accident. For investigators, this acoustic data is invaluable. It helps to time the sequence of events and confirms that the power loss was not a gradual reduction but a complete failure. The high pitch of the rat's whine indicates it was spinning rapidly, which means the aircraft still had considerable airspeed when it deployed, consistent with a failure occurring just after the plane became airborne. The sound tells a story that the visuals alone cannot. It is the sound of a modern airliner that has lost its voice, replaced by the high-pitched hum of its last-ditch survival system. The evidence for a dual-engine failure is not confined to what can be seen and heard on a video. It's, reinforced by harrowing accounts from within the aircraft itself. The crash of Air India 171 had a single miraculous survivor, a passenger seated in seat 11A. His testimony provides a crucial human perspective on the mechanical failure. He reported hearing a loud bang shortly after the aircraft lifted off the runway. This sound was immediately followed by the cabin lights flickering. This sequence of events aligns perfectly with the deployment of the Ram Air Turbine. The loud bang was likely the sound of the rat's compartment door being forced open by explosive pyrotechnic charges, which is actually a standard method for ensuring rapid deployment. The subsequent flickering of the lights is a classic sign of a power transfer. As the main engine generators went offline, the aircraft's systems would have momentarily lost power before the rat spooled up and the emergency generator began supplying electricity to essential systems. The survivor in 11A was not just a witness to a crash, he was a witness to the exact moment the aircraft's emergency power system activated in response to a catastrophic failure. Further corroboration has emerged, though it remains unconfirmed by official sources. There are credible reports circulating within the aviation community that the flight crew of Air India 171 issued a mayday call in the seconds before impact. In this distress call, the captain is said to have reported that they were losing thrust. If verified, this radio transmission would be the most direct evidence of all. It would represent a confirmation from the pilots themselves that they were dealing with a power loss, not a configuration issue. A call about losing thrust is the unambiguous language of engine failure. Taken together, these pieces of evidence from the video, the audio, the survivor, and the unconfirmed ATC report create a powerful and cohesive narrative. Each element supports and strengthens the others. The rat is seen on video, its characteristic sound is heard on the audio track, the physical sensations of its deployment are felt and reported by a survivor, and the pilot's own words may have described the engine failure over the radio. This is no longer a theory based on speculation, it's a conclusion built on a foundation of converging, multifaceted evidence that points in only one direction. Before the new video analysis emerged, the leading theory for the Air India 171 crash was centered on a specific type of pilot error: premature flap retraction. In this scenario, it was hypothesized that the pilot flying, intending to retract the landing gear after takeoff, might have mistakenly moved the flap lever instead. Retracting the flaps too early and at too low an airspeed would cause a sudden and dramatic loss of lift, leading to an aerodynamic stall from which recovery at low altitude would be impossible. This theory was compelling because it explained the aircraft's failure to climb and the fact that the landing gear was still down at the moment of impact. This explanation seemed plausible because such errors, while rare, are not unheard of in aviation. The cockpit is a high-pressure environment, especially during the takeoff and initial climb phases of flight. The layout of the controls for the flaps and landing gear can be adjacent, creating the potential for a misidentification under stress. The aircraft's slow, wallowing flight path before it crashed seemed consistent with a plane that was on the verge of a stall, struggling for lift. Without any obvious signs of fire or smoke from the engines, investigators naturally turned their attention to the pilot's actions and the aircraft's aerodynamic configuration. However, the new evidence pointing to the deployment of the Ram Air Turbine fundamentally undermines the flap retraction theory. As established, the rat only deploys in response to a massive power or hydraulic failure. A pilot mistakenly moving the flap lever would not trigger its activation. The aircraft's systems would have registered the flap movement as a valid, albeit incorrect, command. The engines would have continued to produce full takeoff power, and the electrical and hydraulic systems would have remained fully functional. The deployment of the rat is simply incompatible with the premature flap retraction scenario. Consequently, this once leading theory has been relegated to the background, now considered highly unlikely. The landing gear remaining down is no longer seen as evidence of a pilot confusing it with the flaps. Instead, it is now understood as a logical consequence of a total power failure. Faced with a silent cockpit and a dying aircraft, the pilot's absolute priority would have been to maintain control using the limited power from the Rat. Retracting the landing gear would have been a secondary, non-essential task in the face of such a profound emergency. The new evidence has not just introduced a new theory, it has effectively disproven the old one. In the midst of the almost complete devastation of the Air India 171 crash, an event occurred that can only be described as a miracle. A single person survived. This lone survivor was seated in 11A, a window seat on the left side of the aircraft, positioned directly over the wing. This location proved to be critically important to his survival. The wing spar, the main structural component of the wing that runs through the fuselage, is by far the strongest part of an aircraft's airframe. It is designed to withstand immense forces, and in this case, it likely shielded his immediate area from the full violence of the impact. His experience provides a unique and invaluable window into the final moments of the flight. As the plane came down, he was in a section that remained relatively intact. After the horrific chaos of the crash, surrounded by wreckage, he found himself able to unbuckle his seatbelt. In a moment of incredible clarity and fortune, he realized he was right next to an emergency exit door. He managed to operate the door, opening it to the outside world. He then jumped from the fractured fuselage and was able to walk away from the burning remnants of the Boeing 787, becoming the sole witness to emerge from the disaster. His testimony, as discussed, provides crucial clues about the mechanical failure, the loud bang and flickering lights consistent with Rat deployment, but it also offers a human story of chance and circumstance. Survival in a high-impact post-crash fire scenario is exceedingly rare. It depends on what experts call the survivability triad: an impact that is survivable for the occupant's location, a usable exit nearby, and the time and ability to get out before the environment becomes lethal. The passenger in 11A found himself at the nexus of all three fortunate conditions, a statistical anomaly in a field of tragedy. The story of the lone survivor is a stark reminder of the brutal randomness of air disasters. His survival was a product of his specific seat location, the way the aircraft broke apart, and his own ability to act decisively in the aftermath. While his account is vital for the investigation, it also stands as a powerful human element in a story that is otherwise dominated by technical analysis and mechanical forensics. It is a narrative of improbable survival against overwhelming odds, a sliver of light in one of modern aviation's dark and perplexing mysteries. In the immediate aftermath of any air crash, official investigative bodies move quickly to secure the scene and issue preliminary findings. In the case of Air India 171, India's Aviation Herald released an initial report that attempted to rule out several potential causes. Based on a physical inspection of the runway, they concluded that there was no evidence of a bird strike, as no bird remains were found. This was an important early step, as bird ingestion is a known though rare cause of dual-engine failure on takeoff. The report also initially downplayed the likelihood of a twin-engine failure, leaning, like many early analyses, toward some form of pilot error. This initial assessment was based on the information available at the time, which was limited. Without clear signs of engine distress like fire or smoke, and with the landing gear down, the hypothesis of a configuration error was a logical starting point. The official investigation was proceeding down a path that assumed the engines were functioning. The preliminary reports reflected this mindset, shaping the public and industry perception of the accident. The idea of a state-of-the-art Boeing 787, with its highly reliable engines, suffering a simultaneous flameout, was considered so improbable that it was effectively placed on the back burner. The emergence of the new video, and its subsequent analysis, has forced a dramatic confrontation with these initial findings. The clear evidence of the Ram Air Turbine's deployment directly contradicts the early assumption that the engines were working. This new reality compels investigators to reopen avenues of inquiry that were previously considered unlikely. The focus must now shift entirely to the power plants and the systems that support them. Why did two engines designed to operate independently fail at the exact same time? This is the new central question that the official investigation must now answer. This turn of events highlights the dynamic and evolving nature of aircraft accident investigation. Initial conclusions are always subject to change as new evidence comes to light. The Air India 171 case is a textbook example of how a single piece of data, in this case from a civilian's camera, can completely upend the established narrative. The official record will have to be amended to reflect the overwhelming evidence of a dual-engine failure. The investigation, which started with a focus on the cockpit, must now expand to include the engine manufacturer, the fuel supplier, and the airline's maintenance procedures to solve this deeply troubling puzzle. The new evidence has solved one major mystery of the Air India 171 crash. We now know what happened. The aircraft suffered a catastrophic loss of power from both of its engines moments after takeoff, leading to the deployment of the Ram Air Turbine. The visual and auditory proof is compelling, and it is corroborated by eyewitness testimony from the flight's sole survivor. The narrative has shifted decisively away from pilot error and toward a fundamental mechanical or systemic failure. We have moved from a question of crew action to a question of machine failure. The flight crew was not at fault. They were victims of an impossible situation. However, in solving one mystery, the new evidence has given rise to a deeper and more disturbing one. Why did it happen? The simultaneous failure of two modern high-bypass turbofan engines is a real head-scratcher for the aviation industry. These engines are designed with immense redundancy and are built to be incredibly reliable. The possibility of a common mode failure, where a single cause takes out both independent power plants, is a scenario that aircraft designers and engineers work tirelessly to prevent. The failure of Air India 171 represents a breach of those fundamental safety principles. Several possibilities are now on the table, but none are simple. Fuel contamination is a leading candidate. If the aircraft was supplied with tainted fuel, it could certainly affect both engines simultaneously. This could be due to water, microbial growth, or the accidental introduction of the wrong type of fuel. Other possibilities, though more remote, include a major software glitch in the full authority digital engine control systems that govern the engines, or an unprecedented and undetected atmospheric condition. Investigators will be meticulously analyzing the fuel samples, maintenance records, and the engines themselves to find the root cause. The crash of Air India 171, as it is now understood, stands as a critical and sobering event for modern aviation. It highlights a potential vulnerability that was considered almost theoretical. The rat did its job, but it is a system designed for the high-altitude environment where time and altitude are resources a pilot can use. At 400 feet, it could only provide control, not salvation. The answers that are eventually found by the official investigation will have far-reaching implications for the design, maintenance, and operation of all twin-engine airliners around the world, ensuring that this particular chain of failure can never happen again.